In this video, we'll look at custom VIs in SoundCheck 16. One of the changes made to SoundCheck 16 custom VIs is that the connector pane, where you set the inputs and outputs, have been frozen to the SoundCheck 15 version and will not be changed in the future. If you recall what we discussed when we were talking about SoundCheck 15 VIs, anytime SoundCheck was upgraded and anything inside of a SoundCheck step was changed, upgrading a custom VI between versions would require making those changes in the VI itself. Now, in the future moving forward, end users will not have to rewrite code because of changes that we've made in SoundCheck. In addition, VIs that are called in custom VIs, such as the unflattened results VI we had to use in the previous example, have also been frozen at the SoundCheck 15 standard. Overall, upgrading should be much easier from 15 to 16 and 16 moving forward. There is also a VI included with SoundCheck 16 that will help with recompiling older custom VIs. The templates should also be simplified. In older versions of SoundCheck, there were a lot of case structures that were supposed to just be ignored by the user, and we've tried to clean those up so it's a lot more simplified, and there's not a lot of unnecessary exposed code. Another thing that was added is the verdict of the step. In SoundCheck 16, when a step successfully executes, it will be shown as green, and when the step fails to execute, it will be shown as red in the sequence editor. Now we'll take that output memory list sequence we wrote in SoundCheck 15 and show the process for upgrading it to SoundCheck 16. To do this, we'll go into our SoundCheck 16 64-bit folder, into System, Custom VIs, and select Open before converting old custom VIs. We'll open this using LabVIEW 2016. There are some instructions here on how to convert the VIs from a previous version of SoundCheck. So first, we'll copy the custom VIs into this version's custom VI folder. Open this specific VI that we already have open in the version and business we're upgrading to, which is LabVIEW 2016 x64. And with this open, we'll now open the custom VIs we are trying to convert. There's also a couple specific issues that you may encounter, which are written at the bottom. If either of these apply to your custom VI, make the appropriate changes. We'll go now to the SoundCheck 15 Custom VIs folder and copy the VIs we want to upgrade. Memlist output in Memlist output editor. Move back to the SoundCheck 16 Custom VIs folder and paste them here. The VI for converting old custom VIs is open in the background, so now we'll just open these memory list output VIs using LabVIEW 2016. And that's it. We don't need to make any adjustments now that these are open. We'll just save them and try to use them in SoundCheck 16, which was in beta at the time of this video recording but is now released. We'll create a new sequence called memlist output test. And now we need to create a custom step. So we'll right-click on Custom, select New, and enter the name memListOutput. Again, this needs to match one-to-one with what the name of the custom VI is. We'll drag it into the sequence, double-click it, click OK. We run the sequence, and we get our data. This VI has been successfully upgraded from 15 to 16. Upgrading a VI from SoundCheck 15 to 16 or from 14 to 16 should be fairly straightforward. In general, the further back you go, the more likely it is that something in that custom VI calls something that is no longer supported. So if you are upgrading a very old custom VI, there is still the possibility you might need to make some manual edits to make sure it is compatible with SoundCheck 16. Now let's take a look at writing a SoundCheck custom VI from scratch. One common use of a VI is to read the serial number from a device and store it in the serial number field. We're just talking to an Agilent digital multimeter, which actually doesn't have a serial number return, so we're just going to grab the model number and store that in the serial number. As far as SoundCheck is concerned though, the structure of the custom VI would be the same either way. We're also going to return the error status as a step verdict. If the step doesn't execute correctly, we want the step to fail. So to create a new custom VI, we're going to copy your step name here editor, paste them into the same folder, We'll rename this to Agilent to serial num, and Agilent to serial num editor. Before we open those steps, I'd just like to point out we have an Agilent model number VI already in this folder. This was created before the video, and it's what we'll use to actually communicate to the device. So given a specific COM port, we talk to the Visa resource COM5. When we run the VI, it returns as Hewlett-Packard with the string, and we extract the model number from that string. This is an example of a VI catered towards a specific device under test. Depending on what you are trying to test, this would need to be customized. We'll look to call this custom VI to return this model number information and relay that to SoundCheck. So we'll open up our Agilent to serial number custom VI, call our Agilent model number code, and return the model number from it, and then interface that with SoundCheck. Let's take a look at the editor and some of the differences between older versions of SoundCheck. There's still some code over here that end users should not have to touch. There are no longer individual controls on the front panel that need to be packaged together in a container. The container is already there in the front panel and it's already bundled together. There's just code here for what happens when you select save, cancel, or timeout. Down here at the bottom is very similar to what we saw in SoundCheck 15 and previous. It's where we enable our curves, values, waveforms, and results, and where we can set those names and units. Here in the editor, we actually do need an input. We need to have a COM port to select which COM port communicates with our RS-232 Agilent device. We're going to right-click on parameter A and replace it with a Visa resource. We only need one parameter here, so we can just delete parameters B and C. These were again created using our template, which are read-only. So to change these, we'll need to go back to Explorer and change the attributes to not be read-only. We'll actually rename parameter A to be something more meaningful. We'll call it COM port, so when an operator actually opens this step, they'll know what they're selecting here. We're not outputting any curves using this VI, so we'll just disable this frame. Waveforms and results are disabled by default. That's all we need to do with the editor. The next step is to open up the Run VI. The first thing we need to do is match this over here to what was in the editor exactly. So just like we did in the editor, we'll need to replace parameter A with a Visa resource, and then change the name of parameter A to COM port. B and C are unused, so we can just delete those. Let's take a look at what's new here. So there's a lot less code than there was in older versions, and all that we expose is what's needed to give you your inputs. Down here is an example of how to read data from the memory list, which we're not going to need, so we can just delete that. And over here is the same code to output the actual data to the memory list. In this example, we don't need to output a curve, so we'll disable it. Remember, in the editor, you create placeholders, but in the Run VI, you actually create the data. This is just some example code that will display here on the screen. We don't need that, so we'll go ahead, highlight, and delete it. So now we're left with a COM port from the editor step, and we want to save that to the SoundCheck serial number field. Here we'll select an external VI and point to the code to read the model number from the Agilent. We want to input the COM port to this VI and then output the model number to the serial number field. The easiest way to do that is to take some of the example code we include in another custom VI. There's a template included with SoundCheck called serial number write read. We'll open it up and see the relevant code. There's this section called SoundCheck set serial number. It sends the serial number to SoundCheck with this VI call. So we can just highlight that and copy that over to our other VI. If you look in the SoundCheck manual, we include a lot of information on how to communicate with SoundCheck using TCP/IP. There's also the syntax of commands on how to control it, and all of those can be sent through this VI right here. So we can use some TCP/IP commands in the middle of this custom VI to actually set the serial number in SoundCheck. That's all we need to do to read the model number from the Agilent and set it in the SoundCheck serial number field. The other thing we wanted to do in this VI is output a pass-fail status on the step. If we don't successfully read from the Agilent, we want the step to fail. We're going to pass the error wire through this Agilent model VI. Then we'll take the error status from talking to the multimeter and use that to decide whether to pass or fail the step. So here, if the status is true, that means there was an error talking with the device, so we want it to fail. So what we'll need to do is invert this. If the error status is true, we want the verdict to be false, and if the error status is false, we want the verdict to be true. Now we want to pass the verdict out, not the result. We'll enable the frame that's used to enable the result to the memory list, and then do a special trick. We'll go over here and wire step name as the name of the result. This is a specific feature of SoundCheck. If a step outputs a result that's the exact same name as the step itself, SoundCheck treats that as the verdict. So now we'll just take the verdict from the status through the inverter and wire it here. Now we're all set. We can save this VI and then take a look at the custom step inside SoundCheck 16. We'll create a new sequence and call it Agilent to serial num. The name of the sequence doesn't matter, this doesn't need to match the custom step. But here in the custom step, this must be exactly the same name as the VI we just created. The Agilent's currently connected on COM port 5, so the goal would be if we hit run, it takes the model number and stores it in the serial number field. We run the step now, however, and we get a failure. And you can see here that the step is now red. The verdict that we sent out tells us there was an error code, and so the step failed. So the reason this step failed is we didn't have the COM port selected in the editor. So in this dropdown, we'll select COM port 5, which is where my Agilent is connected, and rerun the sequence. Now the sequence runs, we see the model number appear in the serial number field, and the custom step shows green for passing. There was no error messages this time.